Hi, this is Tushar again. Hope you have understood that there are the two types of lightning which I explained in last video, positive and negative lightning. Both are very dangerous, and mostly we have to consider that negative lightning, charge discharge from the atmosphere, is considered more dangerous as it needs very less amount of opposite charge, that is positive charge, on which it can strike. So it doesn't need that much of high amount of positive charge to strike on. So we have to protect our structures and buildings from positive and negative charge. Both are dangerous. Both can have way impact on any structure according to the hazardous structure or finance, you can say, consider it can cost you a lot. And one more thing I was thinking, that as per your assumption, what should be the amount of the current we should consider if we are considering lightning? It should be 100 kiloamps, 300, 400, 500, how much? Or 50, 10, whatever your assumption or whatever your knowledge is, please share, comment it. As I am a power engineer, I am a designing these types of stuffs for substations, earthing, industrial earthing, industrial lightning protection systems. So I will also try to exchange my thoughts and informations with you, as these are the information, these are the techniques which we cannot study from the books. These are from the experience, or you can go with some standard which are already been made by the researchers and typically industrialists which are working in this. They have spent the whole life in this industry. So today I was thinking that what if we can divide the sections as per my thinking, as I am working. So as per my point of view, I can, from my own theory, it's not been some written or something, but I can consider that lightning protection I will categorize in three sections. Firstly, the industrial. Secondly, substation. Third, which is majorly the vast, that is uh, commercial buildings or residential areas which can be of any height, like 10 meters to 300, 800 meters. We have many of the buildings which are crossing the height of 300 meters also, 700 meters also. So suppose that much, at that much of height, how much charge they can carry on their from their surrounding and vicinity, and how much vulnerable they will be. So special techniques are used for more complex, I think, substations, because they already have like tremendous amount of voltages, they can carry charge. So these things, substations and buildings which are above 60 meters, as per, if I consider IEEE 80, it states that if you have to consider lightning protection, so specifically you have to consider the ESC system which are more than 80 meters. There is a gap between 60 meters to 80 meter, that is 20 meter, which is still like a bifurcation field of height, in which we have to consider which type of systems we have to consider. So if we go through different types of structures, it will vary. If we are considering the lightning or earthing, it will vary for each and everything. Lightning can be correlated with EMI, EMC studies, or power system studies, or I can say fault detections. Everywhere you will consider that somehow, because see, every system is being designed and programmed, or I can say installed, considering some limited amount of current. And in electrical systems, that much current is not considered for any of the system in any of the electrical appliances or any of the electrical industry, that a single lightning can hold. As we all know that lightning is also a different concept. This is not, if we are considering that the spark is there, a simple spark will come. It's not like that. It's like a, you can say that's a high amount of charge. You can consider there's a like a big like tank of charge is there on the roaming on the atmosphere, and it will drain only at that point where it can get a pass. Consider this as a tank which has a pipe which is going to the ground, so it will settled when you will throw water, it will settle when it is being spread on the ground, simply as same as with the lightning. So when the lightning is lightning process occur, so it is not a single charge, it will be like hammering 1 2 3 in a fraction of second, in a nanosecond basically. So in that much charge, any of the metal if you are considering if it is not considered to handle that much of current, we are not giving that much of consideration for the lightning procedure to withstand this much, so it will definitely enter our electrical system. And you know, the wiring, the circuitry are not that much, like you can have like 3 mm 4 mm of copper or aluminum, any conductor. If you are heavy 3 phase or even single phase is very thing, but 3 phase also, they cannot withstand that much of current, they will burn out when the charge that much. See, simply we can consider that there is a pipe, simple pipe is there, water hose is there, and you are throwing water from one entrance to the second. If you will throw normal tap, if you open a single tap, so it will be the volume of the water which will be coming now, so it will be less. But if I consider that you have a hose of this much and you are connecting a pipe of this much, so volume which is coming from the bigger entrance will get a heat or pressure on the point where it is coming from this much, so half of or like 1/10 of the size. So at that particular time it will heat up and it will burn. So we are considering as the cables, conductors, as a pipe which are helping to pass the current, the charge, which is the current is nothing but the flow of charge. So if you are having that much charge and you need to flow, so your conductor should be heavy at least. So mostly we use like 25 into 6 mm GI strips for the lightning, which is quite thick for the current. The current capacity is quite high for that. So again, I'm not going to disclose what is the consideration of lightning current which we have to consider. Recently, the standards IEEE has basically changed the value which we like a decade ago, 10 years ago, we used to take like 1/4 of this. So I'm giving a hint. Just tell how much charge you can consider in the lightning. Comment down, and we will disclose that in the second. Hope enjoy the moments. Hope you like the video and please subscribe. Thank you.